I want to spend a few moments to discuss the difference between optimistic concurrency control and pessimistic concurrency control. Now, you might say, Hussein, didn't you discuss this topic? Yes, I did. But every time I come across a database engine, I learn a thing or two. And I add to my bag of knowledge, that makes me want to talk more about it and kind of flush things up. And here's another thing with running a YouTube channel. When you get comments, some comments are so valuable, they point how dumb you are, right? And it says, oh, Hussein, you forgot that MongoDB version 3.2 2 years ago, they added this particular feature and they are no longer to do this. So it kind of invalidates a lot of how you were thinking in that video. So you need to make another video to kind of add that into consideration and see how your thinking changes. So optimistic concurrency control and pessimistic concurrency control is so critical. It's basically the atomic level of how you pick which path decides basically what database you're gonna run. Let's discuss this. Guys, before we start, if you love this kind of content, databasey stuff, make sure to check out my Introduction to Database Engineering Udemy course. Over 14 hours worth of exclusive content. This that you won't find anywhere in the world. Well, you're gonna find it in Udemy. But yeah, you get my point. Yes, good stuff. We have great questions. I try to, as much as possible, to answer most of these great questions. So there's a catalog of great Q&A happening there already. So great lectures, over 100 lectures, I believe, more than that. So yeah, check it out. The link will be in the pinned comment below. Thank you so much. Welcome to the Backend Engineering Show with your host, Hussein Nasser des. And today, I'm going to talk about optimistic versus pessimistic concurrency control. If you don't want to support concurrency control at all, you want to build a single user database that nobody else is going to edit. Just one single user is going to slam and edit the stuff, right? There is no multi-users. There is no ability to do transactions, and there's no ability to do isolation. You know, you're not trying to isolate anyone from your reads or writes for that matter. So if you do that, if you don't do that, you don't have to worry about anything. You can click off this video. But if you do, which most databases do, Postgres, MySQL, MongoDB, most databases need to support multi-user. And don't think of multi-user as web users. We're talking about multiple transactions that doesn't have to come from the same user. Let's say there are 1,000 viewers. Those are technically multi-user, but to the database, they might come from the same database instance user. You're not going to create a different database user for every single web interface, right? You don't do that. So, but it's the idea of concurrency is the key here. And how do you forget about all this mumbo jumbo that we're talking about, concurrency control and all this stuff? How would you stop and think about it? Forget about all the papers that have been written about database systems and take this question and try to answer it yourself. How would you prevent someone from changing a value that you just changed and you want to persist? How do you do that? So you start a transaction and you change some value. How do you then prevent someone else from changing that value? Because that's dangerous, right? Unless that value is committed and the other transaction starts, it should always see that latest change and then have the idea of changing it. If you allow this update to happen, then there is this thing that's called lost update. You made a change, but you turn it on and it's lost. There's a lot of misconception about this, because a lost update only happens in the same transaction. You wrote something, right? You didn't commit yet, and you attempt to read it, and it's not there. That is dangerous because basically it causes corruption. This is not lost update that I'm gonna describe. You start a transaction, you change a field value, you commit, and then you read it, and it's not there. That is not a lost transaction. Why? Because after you commit, someone else could have started a transaction, changed the field, and then committed, and then you read that committed value that transaction that changed. So that's technically not a lost update. So measuring lost update is very hard, but effectively it is almost like you're just reading this transaction history, right? So how would you build a system that prevents these kind of things? A classic example is to use something called locking. Hey, I'm updating this row, I'm gonna lock it. Why? Because I don't want anyone to change that value. As long as my transaction is running, I want to go my own thing. I'm doing update to other fields, to other columns, to other tables. But that value shouldn't really change. As long as you touched it, you changed it, you don't want it to change during your transaction. That's the definition of lost update, right? How do you do that? If you write that value, you can say lock that. You can tell the database to lock it. And by definition, this is a global concept that tells any other transaction that says, hey, if another transaction attempt to write to this row, that particular field, we're talking about rows, not columns here, right? There is no concept of column-based lock, although it's fun, but there isn't. There's only row locks for simplicity. You can build something like that, but it's so expensive. So I lock the row. So other person want to update another field of the same row, they can't. And you can define what that means. Can't. What does that mean? You can fail, or you can make them wait. And that's what locks do. What this model is called pessimistic, because you are so pessimistic that you don't trust anyone. You just say, I'm gonna lock this thing, and I'm just gonna prevent anyone from changing this thing. And I don't care if anyone didn't, because someone, you might just go through the whole transaction and nobody actually tries to touch your row, right? But you take that chance. You're pessimistic. I think the example I give in my other video that I made was it's like taking your umbrella every time you go out, regardless. That's pessimistic, right? Because you think it's gonna rain. Don't get me wrong, I love rain, but if you don't like rain and you think it's gonna rain, you're always gonna take the umbrella with you. I'm talking when you leave the car, not in the car. Of course, you can have it in the car. You can throw it there. But even when you go to the grocery store, you will go for a walk, you take the umbrella with you all the time. That's pessimistic concurrency control, right? If it rained, you have it there, right? You might say, Hussein, what's wrong with this? It seems like this is the best approach ever. Always take the umbrella with you. The umbrella is heavy. The umbrella costs strength. Right? My skinny arm cannot handle the umbrella. Locks are the same way. Locks are expensive. Locks need management. You need to manage locks. They're not free. You think locks are free? They are not. Nothing in this world is free. You gotta understand that everything is a program and everything needs to be coded, and locks need to be coded, and they are so goddamn expensive. They are so goddamn hard to get right. And then now you can get to this, like, oh, there's the idea of row level locks. There's an idea of table locks. There is an idea of page locks, right? And then you can define what all these mean, right? A table lock, that means, hey, don't allow anyone to touch this table. A row lock, that means don't allow anyone to update this. Now I'm gonna ask you this question. How would you implement row level locks? Could be another table, right? Some simple example. Keep in memory a running ledger of all the rows that have been locks. Some of you might say, that's dumb. Why? Because what if a transaction updates 1,000,000 row? Your memory is gonna need to manage 1,000,000 row. Oh yeah. Oh yeah. Well, you have to have 1,000,000 row. Our memory is memory free? No, memory is not free, my friends. Memory is not free. So lock management is expensive. That's French, by the way, for expensive, if you didn't get it. Lock management is expensive, especially row level locks. That's why most databases try not to implement row level locks. And we can get into this row management and dive deep into how each database manage locks. And that's how you pick a database, by the way, guys. It's not because what is faster or what's, it really depends on you and what do you need. I still didn't come to the other concept. We're talking still pessimistic. We're pessimistic concurrency control. So lock management is so difficult, right? And then, so some databases like SQL Server, for example, they manage locks in memory. The moment you put row locks in memory, you're gonna blow up your memory very quickly. So SQL Server have this idea of something called lock escalation, where it says, okay, I'm about to lock 7,000 rows. You know what? If you're touching this many rows, I don't trust you. I'm gonna save memory and I'm gonna put one lock on the entire table. Yikesy. Yes, you just lock the entire table, right? Which is sometimes, it is memory efficient, but you cause more weights on other transactions. And if those transactions are long running, that update all rows, you are doomed, my friends. You are doomed. So SQL Server, you can tune this. That's where database tuning comes in. Dark Horse Coffee Roasters are one of the best. Come to San Diego and check them out. Not sponsored, by the way. Other databases, which is my favorite, Postgres, manage row locks in disk. And you might say, Hussein, that's just dumb, because in disk, that means I have to write to disk to lock the table. Well, if you think about it, if you write to a row, aren't you writing to disk anyway? How about we just lock it there? Okay, so they are smart. And I don't have time to explain the details on that. I don't even get the level of details. There are these inline hint bits. They manage all this stuff. And I would like to talk to someone from the Postgres maintainers to kind of pick their brains on how they build things. But this is what interests me. I love this stuff. I love to talk about these different decisions that engineers make based on, like, if you go this way, you go this way. If you go this way, then you go this way, right? You can build completely. That's why databases go completely different path based in a simple decision that they make, a branch decision. So Postgres don't put the locks in memory, but they do it on disk. So that means they have more I/O. SQL Server, on the other hand, put it on memory, but you have lock escalation and all that stuff, right? MySQL, I don't remember what MySQL have. I believe it might be in memory as well. I might be wrong there, but they use a different approach. I forgot. But yeah, every database uses different things. So let's stop talking about pessimistic concurrency control and let's go to the lock-free optimistic concurrency control. We are optimistic people. We are open-minded. We like life. And we are pro-humanity. I don't know what I'm saying. We are so optimistic that we say, sir, you can update this field, you can update this row, and we're not gonna lock it. Why? Because chances that some other transactions are gonna update it are really low. Let's be optimistic a little bit. Don't take that damn umbrella with you. If it rains, well, you can just go to the store and buy one, or just run. Okay, you're gonna get a little bit wet. Who cares? So that's optimistic concurrency control. So what does that mean? That means if you update a row, just do your own thing and then commit. But during the commit, we're gonna do a slight teeny beeny check at the commit level. We're gonna say, if the row change underneath you, we're gonna fail your transaction. Some of you might cringe at that. I understand. But hey, just retry it. You're gonna get wet. Go change your clothes, son. It's okay. Who cares? It's just a little water. It's a little bit of water. British is a little bit of water. قليل من الماء لا يضر. So it doesn't, little agua doesn't hurt, okay? So it's okay. So if it fails, just roll back. Fail, give the user a little bit of a beautiful error that says, okay, just chill. It's not a big deal. And MongoDB is this model. Uses this thing that's called WireTiger, and that I'm researching more about. WireTiger is exclusively, it looks like it's a exclusively log structure merge tree, and designed around the idea of having it uses multi-core, it tries to suck the life out of your multiple core CPU as much as possible. Try to utilize them to the maximum efficiency, right? And that's what they claim. I'm just reading, right? And the most important part is they use optimistic concurrency control. They say, well, I don't want to deal with the headache of managing my logs. I don't want to take my umbrella with me everywhere I go. Umbrellas are heavy. Stop taking your umbrellas with you. And instead, just be optimistic, my friend. Be optimistic. Why are you like this? Why? It's okay if it fails. Just retry your transaction. So now you put some more burden on the client side to retry the transactions. And most developers might be familiar with this model. Says, okay, yeah, I know. I get these failures all the time. Just retry. Which doesn't sound like a big deal. Yeah, a little bit of code at your end. And to be honest, I don't have a favorite. I just think every use case really depends on which path to take. You want to take the optimistic path or you want to take the pessimistic path, right? Usually databases don't call themselves pessimistic. You're not gonna go to Postgres and you're gonna read their doc and say, oh, we're using pessimistic concurrency control. No, nobody says that, because that's kind of a negative way, right? Nobody writes that. But you're gonna see MongoDB talk about all this optimistic concurrency control, because optimistic is way better than pessimistic, right? But technically speaking, Postgres, MySQL, SQL Server, Oracle even, they are pessimistic. This is, we're gonna deal with locks, son, and we're gonna lock this stuff. All right. Obviously, I might have missed some of the things. Leave them in the comments below this video, YouTube video. Commento this. And I'm gonna see you in the next one. What do you think is best, in your personal opinion? Let's just have a discussion. Let's have a discussion. What do you think is best? I don't think there's a better way, to be honest. So it's like, I kind of prefer pessimistic because it's like, hey, I'm a pessimistic guy. It's like, lock my stuff, don't touch it. Don't touch my stuff. Don't touch my rows. As long, but also I think about this management of the locks, right? That's why I prefer Postgres, right? Yeah, you can see the right amplification results of Postgres because of all this managing the locks and the writes and all that stuff. Becomes a little bit too much sometimes. But if it's a cost you have to pay compared to memory, you might say, hey, I'm going to use SQL Server. I'm going to put all my locks on memory. I'm going to have 2 terabytes worth of RAM. I don't know. I don't even know if that's the thing. Can you put a 2 terabyte RAM? Is there a motherboard that supports it? I am outdated when it comes to hardware. I don't know anything. I'm going to watch some Linus LTT to update my knowledge. Tyler Pez. All right, guys. I'm going to see you in the next one. You guys stay awesome. Goodbye.